Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Diego, who has completed one of our courses online, which is ROS Basics in 5 days. And at the end of this course, you can do a final project on a real robot, and you can control a real robot through this final project. So that's what we're going to be seeing today. We're going to be seeing the project for Diego for ROS Basics in 5 days. So hello, Diego. How are you doing?
Hi, how are you? Fine, thank you. And you?
I am good, thank you. Very excited to see your project. So whenever you want, you can start sharing your screen and show us what you've done.
Okay, I'm gonna be honest, I'm a little nervous,
Don't
but
worry.
let's see let's see if it works. Basically the project, what it needed to do is one, follow the wall.
Mm-hmm.
Two, first find the wall and position the robot in a great place to
Mm-hmm.
start following the wall and publish the odometry tracker.
All right. So we should see then the robot find the wall, then go around once, and then at the end spit out the how long it traveled.
Yeah, I didn't stop the robot after one lap, but we are gonna see the result in this
Yeah,
terminal.
that's fine. That's personal preference. All right.
Okay, so what's doing right now is finding the well.
Uh-huh.
Uh, what I did is gonna rotate at that speed until the front lens
Uh-huh.
measures the same distance as the smallest well.
Right. Better slow than quick and for it to miss the
Yeah,
spot.
okay, it was supposed to find it there. Let's give it one more. Okay, it did. It did find it, and since we were at the right distance, it
Uh-huh.
didn't readjust the distance. Or why? So I'm getting an error. So here says that it already started the following program. However, it appears it's still rotating.
It's
So
still
I'm gonna
rotating?
yeah, but it's shooting.
Okay, then
Okay, so let me just grab a list of commands I have here. I
good idea.
think it was this one. Yep. Just to stop the robot and start over again.
Well, you can
Wait, I
also,
need to. Yep.
just so you know, if you just kill the node, the robot should stop.
Ah, okay, in the simulation it
Yeah.
did it.
Right. No, yeah.
Okay. So I just killed the node and the robot. Okay. So it didn't. Okay, let me just.
Oh, it definitely is moving then for some reason.
Yeah. I cannot control it. Okay, yeah. I think that yeah, there is it. Okay. So let me try again. Uh actually like this never happened like before.
Yeah, no,
But
it's weird that it was moving without you doing it. So maybe something else was running, but let's just, yeah, start again. Yeah, get in a corner there.
okay. So I'm gonna move it a little forward. There is perfect. Let me try again.
So what is that output
Oh,
there? No way.
okay, yeah. So I was debugging.
Uh-huh.
This I was measuring the arrays and the distance that was recorded because I was wondering if the front was exactly the 360
Right.
uh, list on the array.
Right.
So we adjust and down it should start, but it isn't. Like it's really weird because on the console it says that it has already started and it's spinning. So let me
Yeah.
just
And
Um,
but look, it started
yeah,
moving just now. So can you just go back to the camera? Oh
yep.
no, it's just still spinning. Sorry.
Yeah, I'm sorry. This never happened before. Like, and the weird thing is, for example, here is publishing the distance. So in
Yeah.
theory, it's already out of this node. And once it's out of these nodes, it's going back to the speed and it's publishing this linear speed because it already has gone
Yeah. I have an
this
idea,
way.
Diego.
Yeah,
So why don't we stop this first terminal? Just
yep.
Control C it. First, let's check if the other two, because I'm not sure if the other two terminals are running something. I don't think so, but I just want to make sure.
No.
All right. There's a weird behavior that it starts going backwards when you kill the node. You saw that? It started
Yeah,
moving backwards. So
yep.
let's do this, because I have a feeling something you just reserved this like in the past hour or so, right?
Yeah.
The robot. Maybe something went wrong that for some reason someone else might be controlling it, which would be very weird. But what I wanted to say is, why don't we, instead of launching the whole thing that, calls the service and does that, why don't you just start right away with the wall following node? So you could do like a ROS run of your main node without the service, right? So it would start doing that, right? So it would be wall
Okay.
follow probably.
Okay, yeah. So on the wall flowing node, I have the servers, but let me just comment
Oh, it would
that
call
out.
yeah. I see what you're saying.
I think that's everything for that node. Okay.
Yeah, let's see if that does it.
So that workspace.
Mm-hmm. That can make.
Make.
All right.
That's right.
You see, now it starts right away. So we'll see if it's
Yeah.
something, maybe it's something to do with just one part of your project, which might be just the
Yeah.
service.
Okay. This action trouble, I forgot to remove it. Actually, you can see it on the feedback. Let me
Nice.
just pull that up. Okay, so this is the result. I'm gonna hit enter, but let me just copy the ROS topic
Yeah, it's the
feedback so we can
feedback.
see the actual distance travel.
Nice.
So this is adding up the distance that's traveling, and after one lap,
We'll
we
see
should
a
see
result.
here a list of odometries.
Uh-huh. And how did you do it so it would print out the result? Did you do just like when it reaches 5 meters or something, or how would you do it?
No, I saved the values, the initial values,
Oh, nice.
and give it like a square, right?
Yeah, like a radius. Nice.
Yeah. So as we can see, distance and the angle. So
Nice.
now let me explain a little bit about the code. About the
Perfect.
code.
Yes,
It's
please.
unfortunate that the Wild Finder didn't work because it was the hardest one. But let me explain what I did.
Uh-huh.
So project overview, I already said it. While following logic, very easy. Didn't do this. Sorry. So basically, it's gonna if the distance at the right wheel is less than 0.2, the angular velocity increases. If the distance is greater than that, the angular velocity decreases.
Mm-hmm.
And the first if is that if the distance in the forward sensor is less than 0.5, the angular has a big increase. We can see it here on the code. Wall flowing. Right, so we have a big angular increase, and that works perfectly for wall following.
Yeah.
And then and else, well, if the distance in the right file is between 0.2 and 0.3, it will just move forward.
Mm-hmm.
And then the wall following, I didn't have any like problems in this one. This was really easy.
Mm-hmm.
In the service, that is the wall finder, I have the logic first is find the smallest distance. This can be done with the laser scan. Has a property that is the smallest distance. Okay, and then you rotate um the robot into the smallest distance is in the front.
Yeah.
Then you readjust the distance. If you are too close to the wall, you need to move back. If you are too far from the wall, you need to move forward until you are about 30 centimeters away from the wall.
Mm-hmm.
And then you save that distance that the robot is measuring in front, and then rotate to the left until the right side is facing a similar distance, right?
Mm-hmm.
And then you start the program. So problems I had is that you need to define a margin because distance is not always the same, right? So if you rotate, maybe the robot moves like a little bit, thus the distance will be not exactly the same. So you need to define kind of a margin
I see what you're
to
saying.
of error. You can see it here in the code. Find while, and I define, so this is a class, so I define a margin of 0.05.
Ah, I see. I see.
Okay, so first it goes to callback, and if you see right here, I'm searching for that margin, right? If it's between that margin, then it would stop, and
Mm-hmm.
then the next section will begin. Another problem I have was with infinity. If you're
Yes.
too close to the wall, the output of the laser is infinity. So you just take that into consideration, right? So in this case, in the readjust, if I'm in a smaller distance than 0.3, or if the sensor reaches infinity, I need to move back because I know I'm too close to the wall.
Okay. Yeah.
And other thing I have, it was ROS clock not being published when I run the code. This was a very simple solution. ROS spin once
Mm-hmm.
in a while loop, saving the scan data. This was a very difficult solution, well, problem for me, because I'm used to programming in Python, so
Mm-hmm.
I don't work a lot with pointers. But the problem was that I wanted to save the message from the scanner in a variable that was public to every property in my class, right?
Right.
So the way I needed to define the scanner was not clear for me, and at first I defined it like this way, but actually I needed to define with a constant pointer because it is the way that it's defined in here, right?
Yes. Yes.
So that was a problem. And saving the scan data. Okay, yeah, that what I said, and then I have other problems that the code was going faster than what the callback scan was being called, right? So for that, I just added a simple flag, right, to not start the program until the flag was true,
Received.
right?
Okay.
Because
Yeah.
then I will receive some kind of errors.
Mm-hmm.
And the other problem was discounts, because the find wide wall, you need to find the smallest distance, and sometimes
It's the
in the
obstacle.
simulation, yeah, the cones are too close to the robot, so the smallest distance is actually the cone and not the wall. So the solution was actually just to remove the cones, but it was a problem I was having.
Mm-hmm.
And then with the odometry tracker, this was done with Action Server. Actually, this was kind of easy, but let me explain a little bit about the logic. So first, it was record the odometry. Thankfully, there's a topic in ROS called odom, which has everything you need. Um, but a very important point is I put it in a problem is that there is no angle, Euler angle as they ask you in the problem, right?
Yeah.
So I just like search like how to can I transform uh, quaternions
Mm-hmm.
to Euler,
To Euler.
and there was a very simple formula. So I just used this function to get the jaw of the robot, right?
Mm-hmm.
And this is the constant of p, right? Every callback calculate the display name. So the problem was you don't start at the point 0, 0, right? So you cannot at the end of the lap or at the end of the second you cannot just say you travel X amount, right?
Right.
Because you need because there's displacement and you're going on a loop. So if I say at the beginning and then at the end, the total distance will be displaced will be 0, right?
Yeah.
So to calculate the displacements, I just basically every second I calculate the difference. I save the last odometry and current odometry, and I calculate the difference. And with the simple line distance formula,
Yeah.
I calculated how much it was, and then just added that to total travel, and then published that on the feedback. And then append the current odometry to the results. I save these values, and then just append them to publish. It was let me just search for it. It was request results. Okay,
Yeah, it's
here.
probably the result.
Capture
Yeah.
the. Okay, this was another problem, and the problem is that I was reading the variable that it was point, and the result is defined as point 32,
Yes,
right?
point 32. Yeah.
So so I needed to just copy the information of odometry since well, see the point 32 uh, is based on floats
Mm-hmm.
and the point is based on floats, I can copy the information without like any problem. And yeah, I copy the information and then push that to the result.
To the results. All right. And that's
Yeah.
what we saw in the list of X, Y's, and
Yeah.
Z's. We saw
Yeah.
that.
This is the list. Yeah.
Oh, look, it's
So I'm
still
just
going.
copying the results.
So it's a nice.
Yeah, I didn't stop it.
No, don't worry.
When okay, so the code doesn't stop the robot. It will still go until
Yeah.
the end of time.
It shows your wall following algorithm is robust enough so it can continue for a long time. So that's good.
Okay, it's a very simple algorithm, but
Yeah,
it works perfectly, and
that's the point.
and
Yes.
that's it. So let me talk about the problems. I think I already talked. Okay, and about the checkpoint, right? How do I measure when the lap was finished?
Mm-hmm.
So when I start the robot after the finder, and I'm position, I save that location and give it a margin, right? So in theory, I'm drawing a square in that same position.
Yeah.
And after when I go back to that same square or I enter that square,
It would.
then I know I completed a lap.
All
So
right.
that's everything I'm doing.
Right. Okay. And how do you stop it from ending right away? Right? Because when you start, you're
Okay. Yeah.
in that square.
Thankfully, I was recording the total travel. So I said
Ah,
I know that a lap is
more than
more
1 meter.
than one. Yeah. So
Okay.
exactly. So here's the or total travel is less than one, right? So if for some reason you have a small how we call it pista.
Like a small
Uh,
track.
yeah, if for some reason you have a small track that the lap is less than one, then this is gonna be a problem. But you just change the number.
I see.
But yeah,
Yes. All right.
and that's my project.
Awesome. Well, congratulations. Really nice that it's a really nice project and we can see it's still
Thank you.
working. So congratulations, Diego. I have some questions.
Yep.
So do you mind? Oh no, actually this is fine because I can see you and the screen at the same time. So that's great. So the first question, well, the first comment is really nice explaining the problems you faced. For example, you mentioned that you're more experienced in Python, and you kind of ran into a problem when having to deal with with pointers in C++. And the reason for that is that in order to be more efficient, a pointer is used in C++. So instead of
Copying the data.
instead of looking at the whole LiDAR range, which imagine if it's not a LiDAR, imagine if it's a point cloud camera, which is a camera with depth, and that's a lot of information to be copying around. So what the pointer does is it just looks at the memory address of where that data is stored instead of copying it over. So that's good that you mentioned that, because it shows some of the differences between Python and C++, and why C++ is so much more efficient and quicker. And when they say, if you look at how robots are built inside, everything's in C++ because you can control that as well. And I really like how concise your code looked, and your presentation was also very, very clear. But I guess my one question is, let's try and find out why the wall follower node, let's not find out, but why do you think the wall finder couldn't find the wall, and what maybe, do you know maybe what caused that strange behavior? Maybe in relation to the simulation versus the real robot or things like that. Is there anything you can think of?
Actually, not, because the output of the terminal was saying in this step, and I'm pretty sure that after that step, yeah, I canceled the angular velocity, but maybe that could be a problem. Or for example, maybe I didn't publish the. No, actually, I don't know why that could happen. And it didn't happen before, right?
So let me ask you, because maybe I have some ideas. When you're looking at the minimum distance, and then you're twisting until the minimum distance is facing the front of the robot, is that one value you're looking at?
Yeah, I'm only looking at one value.
Okay, so that can be one problem right there, because let's say your node is going either too fast or too slow, the frequency of it, and let's say you're right before that is accomplished, you're looking at and it's not the minimum, and then in the next step that your code loops through, it jumps past it. Yeah. So that means it's got to do a whole new lap. So one strategy that people do in these cases, especially in the real robots scenarios, when you're not going to have perfect readings of sensors, things like that, you do a range. So instead of looking at just one laser value, you could do, 20. And that provides a little bit more leeway. That could be one reason. Another reason can be the spinning at which it's going. But you're right. That would be an interesting thing to kind of take a look into further. Why, even though your output of your terminal said it returned, your service was completed, and I think it had to succeed, right, for your code to continue. It couldn't be a failure. All right, so that would be a good thing to see why that happened, because I'm also lost in that sense, because it's printing it out further down the code, so that means it returned. So that I just wanted to mention that, but we can see that the logic is good, and probably if we try it 10 times, it's probably going to work 5 out of the 10. All right, so I also wanted to just mention, I really like how you dealt with infinity values, but when you get too close to an obstacle, but I wanted to tell you that in real scenarios, you're going to find a lot more infinite values, not just because you're too close. A lot of the times, lighting conditions can affect one reading, so you might get an infinite value, even if you're not too close. And that can also cause you to have problems further down the road in case I'm going to deal with putting them to 0 or something. Every infinite is 0, and maybe your code will take that and take different behaviors because of that. So I just want to, tell you that those scenarios in the real robot also happen, not when you're too close. But I really like that you took action, because otherwise it stays spinning, things like that, So that's great. And other than that, that is it for me. Again, congratulations, Diego. Really, really nice project. We can see it's still going. And yeah, that's it for me. So congratulations again. I just want to let me get you back here. Yes, and for everyone else that is watching, I recommend you do the same thing that Diego did here. Once you complete your course, you are able to do a real robot project to kind of solidify your learnings and show the world what you took out of our courses in order to get a certificate. So again, Diego, once again, thank you, and hopefully we'll see you around for more and more projects.
Yeah, I hope so. I keep doing these workshops or courses, and I will keep trying to do the certificate.
All right.
Thank you,
Well,
brother.
thank you, man. So that's it for us, guys. So I will see you next time in becoming a ROS developer for our next presentations. And just remember to always keep pushing your ROS learnings. See you later. Bye-bye, guys.